You have never seen 95% of the universe. No one has. Every star, every galaxy, the atoms in your hand, all of it together is 5 cents on the dollar. And right now, in a clean room in Florida, sits the machine NASA built to hunt the rest. A telescope with Hubble's mirror and 100 times Hubble's eyes. The thing it's hunting bends galaxies. It holds spinning stars that should have flown apart. But it gives off no light, and nothing we have ever built has touched a single piece of it. We don't even know if it's a thing. It might be matter we haven't found, or it might mean our law of gravity is wrong. Roman won't take a prettier picture. It's going to ask whether the universe we think we know is real, or a 5% sliver we mistook for the whole. And the hunter's story begins, of all places, inside a spy program. In 2012, America's spy satellite agency handed NASA a gift: space telescope hardware it had built in secret and never launched, free of charge. One of those mirrors, 2.4 meters wide, the exact size of Hubble's, became the heart of the Nancy Grace Roman Space Telescope. So no, Roman does not outstare Hubble. Sharpness for sharpness, the two are twins. And that was deliberate. A sharper mirror was never the problem. The bottleneck was always the limited amount of sky Hubble can observe at one time. The revolution sits behind the mirror. Roman's main camera is a 300-megapixel wall of 18 separate sensors, each about the size of a saltine cracker, stitched into one giant eye. Every single exposure swallows a patch of sky larger than the full moon. Hubble would need about 100 separate pictures and weeks of telescope time to cover the same ground. Hubble looks through a keyhole. Roman opens the front door. Display one of Roman's survey images at full resolution, and you would need 500,000 4K televisions, a screen the size of El Capitan's entire rock face. NASA's own senior project scientist put it in one sentence: 1 month of Roman equals a century of Hubble. And Roman will not work alone. It is heading for the same deep space outpost as the James Webb Space Telescope, a parking spot 1.5 million kilometers from Earth, farther away than the Moon, in the eternal darkness of deep space. It is a place where the gravitational pulls of the Sun and Earth balance each other out. A space probe can remain there for years while consuming hardly any fuel. Webb is the zoom lens, a tiny patch of sky, staggering depth. Roman is the wide angle, enormous sweeps of sky, over and over, watching what changes. Roman finds the needles. Webb dissects them. Europe's Euclid telescope is already out there, scanning even broader ground. Roman will cut far deeper into its sharpest fields, so each mission checks the other's homework. 3 machines, 1 target, the missing 95%. But a tool is only as impressive as the thing it was built to catch. So meet the prey. The missing universe is not a new mystery. We found its first fingerprint 93 years ago, and we have been in debt ever since. In 1933, astronomer Fritz Zwicky discovered something impossible. A cluster of galaxies was moving so fast that it should have torn itself apart and scattered across the sky. It didn't. Something invisible was holding it together, and by his math, there was many times more of it than of everything he could actually see. Zwicky gave the invisible glue a name: dark matter, a label for the mystery. 40 years later, the debt got personal. Vera Rubin discovered that the outer stars were moving just as fast as the inner ones. The farther out you orbit,
the slower you should move. Every planet in our solar system obeys that rule. Rubin's galaxies broke it. They spin so fast, their outer stars should have been flung into space, and they never were. So, either every galaxy hides roughly 5 times more matter than we can see, or our law of gravity is wrong. That fork, real matter or broken gravity, is Roman's first job. And matter is only the smaller half of the debt. In 1998, 2 rival teams set out to measure how much the expansion of the universe is slowing down. Both came back with the same impossible answer. It isn't slowing at all. It's speeding up. Space itself is being pushed apart faster every year by something no one ordered and no one can point to. We called it dark energy, and it is not a footnote. It is about 68% of everything that exists. Dark matter takes another 27%, which leaves every star, every planet, every atom ever photographed holding the number you already know: 5 cents on the dollar. That is the prey. 2 invisible giants, dark matter and dark energy, and Roman is aimed at both. And while Roman was being built, the case got stranger, because even the 5% we can see stopped agreeing with itself. There are 2 ways to clock how fast the universe is expanding. One reads the Big Bang's afterglow, the universe's baby picture, and runs it forward through our physics. It says 67. The other times exploding stars rushing away from us right now. It says 73. Same universe, 2 speedometers that refuse to agree. And the sharper our instruments get, the wider the gap grows. Astronomers call it the Hubble tension, maybe the most important argument in physics right now. Because if both numbers are right, the standard model of the cosmos is missing a chapter. This is the tie Roman was built to break. And the crack is not only in the numbers. Webb has already photographed small red galaxies so bright, so early, that by our timeline, they should not have had time to exist. In the last 2 years, a new instrument made it stranger. A survey called DESI mapped tens of millions of galaxies. Its data hints that dark energy may not even be constant. It may be changing with time, weakening. If that holds, the force pushing the universe apart has a history, and our simplest equations never allowed it one. Roman's exploding star survey is aimed straight at that question. These are hints, not verdicts, the kind of crack that demands a better measurement. But a telescope doesn't answer a crisis just by existing. It answers with a plan, and Roman's plan is 5 years long, built around 3 questions nobody on Earth can answer today. Question 1. Where is the missing gravity hiding? For 520 days, Roman will sweep a region covering more than 1/10 of the entire sky and measure the shapes of hundreds of millions of galaxies. Every one of those shapes is subtly warped because light bends wherever it passes invisible mass. Mass we cannot see still leaves a lens we can measure. Roman will turn that trick into a map, the largest 3D chart of invisible mass ever attempted. And the map doubles as a trial. Einstein's equations predict exactly how that map should look. If Roman's map matches, dark matter is real stuff, a particle waiting to be caught. If it doesn't match, the missing ingredient was never stuff at all. It's the law of gravity, failing at the largest scales there are. Question 2. How many worlds are drifting out there with no sun? For this one, Roman turns around and stares into the crowded heart of our own galaxy.
photographed every 12 minutes for 438 days. A rogue planet reveals itself only once, by causing a distant star to flare up briefly. A one-time flash from a world that has no sunrise. Some estimates say these orphan worlds may outnumber the stars themselves. Nobody knows the real number. Roman may finally count them. Along the way, it should catch thousands of ordinary planets too, enough to answer with statistics instead of luck how rare a solar system like ours actually is. Question 3. Why is space speeding up? For the third question, Roman becomes a time-lapse camera aimed at the history of the universe. Every 5 days, it will revisit the same 2 fields of sky and hunt for a specific kind of explosion. White dwarf stars detonating with a brightness so uniform that astronomers use them as rulers. Those explosions become mile markers across cosmic history. Together, they reveal whether dark energy stayed constant or changed over time, exactly where DESI saw its crack. This is the measurement aimed straight at the 67 versus 73 fight. Not a new opinion, a new witness. And bolted beside the main camera rides one more instrument, small, experimental, and carrying the oldest idea on the entire spacecraft. A coronagraph, a device that blots out a star's glare so precisely down to 1/1000th of its light that the planets beside it can step out of the dark. Inside, masks and flexible mirrors bend the star's own light against itself until it cancels out. That is like standing in one city and blotting out a lighthouse in the next, just to catch the firefly hovering beside it. On Roman, it is a rehearsal, the test run for the machines after Roman, the ones meant to photograph another Earth. But the idea itself was not born in this century. It belongs to the woman whose name is painted on the telescope. In 1959, just 6 months after NASA was founded, the agency hired its first chief of astronomy, Dr. Nancy Grace Roman. A woman running a science division of a brand new federal agency in 1959 America. And in that very first year, she proposed something the technology of her era could not touch. Block out a star's light, she said, and you could see its planets directly. 67 years later, her idea is finally flying, bolted to a telescope that carries her name. In between, she spent decades convincing committee after committee that a telescope belonged above the atmosphere. The result was Hubble. Colleagues simply called her its mother. She died in 2018 at 93, 2 years before NASA renamed this mission in her honor. She never saw her name on the side of it, but her telescope is about to see for her. And here is a sentence almost never written about a NASA flagship. It is early, and it is under budget. Roman was finished 8 months ahead of schedule, in an industry where its own sibling, Webb, arrived 14 years late. NASA's administrator has called Roman the model the agency wants to copy for everything it builds next. The telescope is at Kennedy Space Center right now. The rocket is a Falcon Heavy. The pad is 39A, the same concrete that launched Apollo 11. Liftoff is scheduled for August 30th, 2026. Then come roughly 3 months of travel and calibration, and if the schedule holds, the first images arrive around December. Every bite of it becomes public immediately. Roman will beam down 1.4 terabytes a day, enough that its first year should return more imaging data than Hubble has sent home since 1990. The same morning a NASA scientist opens a new Roman image, a 14-year-old with a laptop can open it too. A planet flagged by a student, a supernova caught by a retiree. That is how this decade of astronomy is going to work. And if history repeats, Roman's biggest discovery is not on the mission plan at all. Every flagship before it, Hubble, Kepler, Webb, made its most famous find off script. Remember Webb's impossible red galaxies? Too bright, too early? Roman's wide eye will finally show whether they are rare freaks or the rule that breaks the model a second time. Nobody planned for them. Nobody will have planned for what Roman trips over either. So no, Roman is not just a bigger Hubble. Hubble showed us how beautiful the universe is. Roman was built to find out whether it is the universe we think it is. 5 years from now, its map of the invisible will point one of two ways. Either the missing 95% is real, matter and energy we can finally corner, weigh, and one day name. Or the map will not close, and the problem was never what is missing from the universe. It is what is wrong in our equations. Because we have been reading reality off 5 cents on the dollar, and we are about to find out whether we even counted those 5 right. There is more to explore. See you beyond the stars.